Question 224 asks to derive the 1D heat conduction equation for a long cylinder. We assume 1D constant K transient. We have our energy balance. We expand the accumulation term, the generation term, and in and out, and then we put them all together and we cancel out the constants. We take the limit as dr approaches 0, and we get our heat conduction equation for a long cylinder. Question 266, we assume steady state 1D constant K and no generation. We also assume top surface is subjected to convection radiation and solar radiation. This question asks to determine the net flux Q absorbed by the solar collector. Have our energy balance, cancel our generation accumulation, we get dt squared of dx squared is equals to 0. We integrate once to get C1, integrate again to get C2. We apply our boundary conditions, and then we solve for Q using the convection equation. Question 102, we assume steady state 1D constant K and then the heat generation is uniform. We use our energy balance and we cancel out our terms. We get dt over dr is equals to 0. We integrate once to get C1. We apply our boundary condition and we solve for C1. C1 is equals to 0. We integrate again to get C2. We apply our boundary condition. R is equals to R naught to solve for C2. Now that we have C1 and C2, we plug it back into the equation and we solve for the temperature. Question 1440, we assume ideal gas, air is saturated, Henry's law is applicable because the relative humidity is 100%. It says mole fraction, find the mole fraction of water vapor in air, and B, mole fraction of air in water. A, the mole fraction of water vapor in air, that's P vapor pressure over total pressure, and then for B, we just subtract the total pressure from the vapor pressure. And then we get, for Y dry air, liquid side, P dry air over H, we get 1.6 times 10 to the power of -5. Points of confusion, I was quite confused in this question what H stood for. I tried to find, but I didn't quite understand. Also, I'm a little confused on when the heat convection equation is put into the boundary conditions. For example, Q is equals to H, T minus T, T1 minus T2.